compensation and transformation. So compensation, as you read, is when you're adding or subtracting a quantity to one or both of the numbers to make them friendly numbers. And I always talk to my kids about how if we can make a 10, that's great because we like friendly 10s. They're easy to work with. So in this strategy, you must undo the addition or subtraction whenever you're finished, when you get to the end of your equation. And then, of course, with transformation, you have to transform both of the numbers. So if you transform both of the numbers, then you don't have to worry about remembering to do it at the end. So that's the kind of the difference between the two for me. So some common misconceptions that our kiddos have. They subtract the smaller from the larger. We caught that. And then that's a rule that children apply regardless of the minuend or the subtrahend. And that was their example with, I believe it was Lisa that did that. And then not regrouping. Sometimes they just don't. They just don't do it. And then they ignoring the zeros. This is something else that the kids they'll just jump over that when they get to 3-digit numbers that they're subtracting. Okay, so thou shalt not carry. We say that because we are not even supposed to be introducing the algorithm where you would carry to our students until they get in the 4th grade. And we see it introduced all the time, starting even in 2nd grade, it'll be introduced. And lots of times, if it's not the teacher that introduces it, it'll be the parents that will show their child how to do that, because I've had them come into me so many times and say, my daddy showed me how, or my mommy showed me how to do this. And then once that happened, my kids stopped thinking about place value. All they wanted to do was what mommy or daddy had done or what they had been shown how to do. So it's so important not to introduce that algorithm to our kids. There are other ways we can do it, and we're going to look at those strategies. And of course, you looked at those in that chapter as well as you look through. So this strategy, based on place value, the split strategy. So you can look at 38 and 49. So you can think about 38 and think about 49. And what I want you to think about is not only that we can do this on paper, but if a child can't understand that on paper, what do we need to do? What do you think I'm going to say we need to do?
Take it to semi-concrete or concrete.
Absolutely. We've got to build it for them. We've got to let them see it. So, okay. And then it said, then of course, you don't want to think about what we want to do. Well, we're going to, first of all, we're splitting it apart. 38 becomes 30 and 8 and 40 and 9. And then we're going to put our 10s together, which is totally opposite of what we do when we do the algorithm. But that's where we need to start. We put our 10s together, then we work with our 1s. If we've got hundreds and 10s and 1s, we put hundreds together first. We start with the highest amount. We have an activity, whenever we have everybody together, we take play money. We put hundreds and 10s and 1s together. And we just throw it up in the air, and everybody gathers up their money. And then they start counting it. We ask you to count it. And of course, when they start counting their money, how do they start? What do they start with? You start with your highest bills. It's the same thing here, same principle. So we're going to put our 10s together. So that means my 30 and my 40 is going to give me 70. And then I'm going to put all of my 1s together. And of course, when I put those 1s together, I see that I've got 10 1s and 7 1s. I've got 17 1s. And of course, our kids, we've been working. Remember the game we played where we were moving, making 100? We think about that. We've already played that game. We know that these 10 1s can become another 10. So we have a 10 and 7 1s. So we put in all those 10s together, gives us our 87. Okay? So we can model that for the kids. The kids can do it themselves. which is a good point I need to make. I probably haven't made that yet. I'm not driven that home. These tools have to be in the kids' hands. You can't use your document camera and model and show them and think that's you've taken care of the concrete portion. You've not. The tools have to be in the kids' hands. They have to do it. They have to build it. They have to move it. They have to think about what they're doing. So yes, we model for our kids, but we have to put the tools in their hands and let them do the work. Any questions, comments on that one? So yes, we do have to have a good understanding of place value. We have to be able to build those numbers, and we have to have experiences building what 38 looks like and what 49 looks like. That's something that's that foundation we need to build and lay before we start trying to add those numbers together. It's a really good aha moment activity to share with, like Stephanie said, it can be even parents, because lots of times that can be one of our biggest hurdles is parents wanting to show them the old way. They don't like this new math, and they don't like that the new math is just about thinking. And they don't like it because it's something new. It's something they're not quite sure about. So 49 again, same problem we had before, but using the jump strategy. And with the jump strategy, like Stephanie said, it's making those jumps, and you can do an open number line. And what we mean by 49, and then make jumps till you get to 38. So they do the 10s first, and then the 1. Why do you think they did just the 1? Anybody got a thought on that?
Because it was one more to the decade.
Yes, it got to that friendly 10. So that's why you have to talk to your kids about those friendly 10s, because adding 7 to 80 is way easier than adding 8 to 79 for our kids, because 10s are friendly. So yes, that's the reason why they did the 1. These things, these types of strategies are the types of strategies that kids will use when you do your number talks. When you have these number talks, they'll use these strategies, and so they'll explain it, and then you'll record it on chart paper or on the board or something for the kids to see. So not only might they share within groups, but they may share whole group during number talks. Okay, partial sums. Well, let's take a look at these partial sums, what they've done. It reminds me of the split strategy. It's just vertical, what it reminds me of. Which might be a nice way of easing the kids into the algorithm. When they're ready, then they'll be able to, it'll look familiar to them. But you can see they've just started, notice that they started with the higher place value and moved their way to the least, and then they just added them up. So I see this as a nice bridge into the algorithm. Again, when they're ready. And this is partial sums with expanded notation. This is going from that expanded form, from the standard form to an expanded form. And it's just a different way of recording their thinking. They've expanded their hundreds, they've expanded their 10s, and then expanded into show their 1s. And then they just added vertically, and then totaled horizontally. Just a little different look, a different way of recording. And what's interesting is kids will choose 2 or 3 different strategies that they like, and they'll really hone in on those, and you'll see that that's the kind of ones they want to use. But again, sometimes the type of problem should dictate what type of strategy you want to use. So you want to try to encourage the kids to use a strategy that would take the least amount of effort. Okay, let's talk about why do so many kids struggle with subtraction? What's your thoughts on that?
The same reason why it's easier to count forward than it is backwards. And like even with the alphabet, going forward was easier than backwards.
You are exactly right, Melissa. That's it in a nutshell. It's way easier to go forward than what it is go backwards. I say that about my driving as well. I go forward way better than I go backwards. I don't do it as much, for one thing. I avoid it as much as possible. And we find the same thing with our kids. They adding, sure, they take to it way more easily than what they do subtracting. And I think a lot of it's because we don't make a conscious effort to have our kids count backwards a lot. I think if we had them count backwards more than what we do and really made an intentional effort to do that daily with them, whatever we do forward, we do backwards, I think that they would do better with subtraction. They wouldn't struggle as much. So think about 1,000 minus 998. I mean, I've seen it. I've done it. I've been there. I've been at this for 33 years now. I've seen this happen. We teach them to take away or borrow. We don't need to teach them to think about it, what that is. Subtraction as a distance or difference is not understood. I mean, they're not really understanding. If you look at 1,000 minus 998, I mean, what's the distance between those two numbers on a number line? It's 2. But we didn't teach them that. We taught them to take away and borrow. And subtraction is neither commutative nor associative. That's true. We can't, how we were looking at them subtracting from the higher number, no matter if it was on the bottom or it was at the top, whenever it was a vertical problem. That's an issue with subtraction. That it's not commutative and it's not associative. You can't move them around like we can with addition. And of course, our sequence of learning is wrong. We have to think about the value, place value first. Okay, so let's look at place value strategy for subtraction. So what we've done here is, 56 minus 27. 56 is split apart into 50 and 6. 27 is split apart into 20 and 7. Do the 56, you're going to take away the 20, which gets you to 36, and then you're going to take away the 7, which gets you to 29. And then over here, another way of thinking about it is that 56 is split apart into 40 and 16. And lots of times kids don't think about moving a 10 back into ones, changing it back into ones, but that's a great strategy to use. And really, it's actually mimics what we do with our algorithm. Is moving it over, but we would need to model that for them. At 56, we're going to take it, one of those 10s, and move it into, with the 6 ones to have 16 ones. And then 27, of course, is split apart into 20 and 7, and then you just subtract 10s, 40 minus 20, and then 16 minus 7 is 9, and then put it together to get you to 29. So 2 really efficient ways to think about subtracting without having to introduce the algorithm to them. And of course, kids would tell you what they're doing, and they can show you. You can see here how to record that, for kids to record it, which is also important. We need to teach the kids how to record their thinking. That's why during the number talks, when they're talking, you record what they're saying, and that models for them how to record their thinking.
But also keep in mind to tell them that they can also break up the ones. Don't be afraid to break up the ones, because most of the time they'll just break it up into like 50 and then the ones, but they won't break the ones on up. So like they could break that 7 up into 6 and 1 and then subtract on down. So things like that need to be make sure we have that conversation with our kids. There's multiple ways to do it.
Okay, here's your jump strategy for subtraction. We got 45, subtract 27. So we're going to start at 45 on an open number line. We're going to make a jump, 2 jumps of 10 for your 20, get you to 25. And then a jump of 5 to get me to my friendly 10, and then a jump of 2. So on that number line, you need to emphasize to the kids to think about working with those friendly 10s, because it makes it way easier for them to think about it. Because once this is removed, I mean, they get to the point where they can do it in their head if they make it friendly enough. And partial differences, I have to admit, they're complicated to me. There's some strategies that they make sense, and others they're a little more complicated. So 56 minus 23, that gets you to 30. And then 6 minus 3 is 3, and then you put the 2 together. That one's okay. I mean, I can see that one. But then they get a little complicated when your
It's
greater
that
number,
negative number.
yes, when your greater number is not at the top, it gets a little more complicated. So that gets into, it almost gets into the work of an understanding of integers of negative numbers. So 31 minus 18, what they've done is they've done 30 minus 10, which is 20. And then they've looked at the 1. You got 1, and then subtract 8. And that leaves you with a negative 7. And then you subtract 20 minus 7, which is 13. So the kids would have to have an understanding of whenever that number that we're subtracting from is smaller, it'll leave you with a negative amount. So that's the issue with that one for understanding. So before they can use it, they have to understand it, though. They have to understand what's going on with it.
You can use money to discuss that one.
True, yes. Anytime you do think about negatives, money will work, right? All right, so let's review a little bit. Compensation is when we change one or both numbers, add and subtract, and then we compensate. So addition by compensating, 34 and 29, add 1 to 29 to make it 30, add it, and then subtract the 1 back off. That's the problem that I found with compensation with my kids. Sometimes they would forget to take it back off. Subtraction by compensating is you look at your problem. Remember, you want to get it to a friendly 10. So you would make 28 become 30, subtract, and then add the 2 back on. So 53 minus 30 plus 2 equals 23 plus 2, which is 25, which is a lot to think about. But you also can think about that on the number line as well. You can model that on the open number line. My math intervention kids, they struggled with this one, the compensation, because they would forget that they had to undo it. Now, this is what we like to do, the transformation. They change both of them at the same time. If you change them both of them at the same time, then there's nothing to worry about. It's done, and your answer is your answer. So transformation, like 58 and 27, if you wanted to get to a friendly number there, you add 2 to 58 and take 2 off of 27. So you're just moving it from the 27 to the 58. So you're making, so it's the same quantity, we're just moving it. So it becomes 60 and 25, which is easy to add because we got a friendly 10. So mine really liked this one. This was a strategy that they used a lot in making friendly 10s. Subtraction, the same thing, except with the subtraction, whatever you do to one, you have to do to the other, because you have to think about it, and you really have to model that on the number line. You have to show them. When we're subtracting, we're talking about the distance between two numbers. So whatever we do to one number, if we're going to shift it to the right, then we have to shift the other number. We can't make the space bigger or smaller. So whatever we do to one, we have to do to the other. So if you add 1 to both numbers here to get to a friendly 10, then you have 57 minus 30, which is 27. So that was the only kicker, was they have to remember whatever you do to one, you do to the other when you're subtracting. And when you're adding, you're just moving it from one number to the other to make a friendly 10. adding 10. And what they're doing is you're adding 10 to both numbers. It's kind of like the transformation. Whatever you do to one, you're doing to the other. With subtraction, it's in a vertical alignment, which lends itself to looking more like traditional algorithm. But what's different about this is you'll see that they're adding 10 to the 4 because they need more ones here, but they're also adding 10 to the 2 10s at the bottom. Now you're to 26, they're adding a 10 rather to the 26. So they're not really borrowing a 10 per se, what we used to call a regrouping. They're just adding a 10 to the top number and they're adding a 10 to the bottom number. They just happen to be putting that 10 with the ones, which is on top, which is pretty clever. So then that sets us up to where we can do 14 minus 6, which is 8, and then 7 10s minus 3 10s, which is 4. So just another strategy we can show our kids. Some of them will love it. Some of them won't care for it. But we never know which one's going to stick with them. We just have to give them many options. Okay, this is something I want to look at with you all, because this was something I had taught many, many, many years before I had thought about this. Because like I said, I've been around a long time, and we had looked at regrouping and, you know, getting across those zeros, and it would be a nightmare with young kids. This was back in the day before we knew not to do those types of things. So look at what they've done. All you have to do is subtract 1 from 6,000. That gets you to 599. Just remember to do the same thing to your bottom number, which gets you to 3,641, and then you're ready to subtract. There is no room for mistakes as far as regrouping and all those things. It just makes so much more sense. And the same thing here with this one here. Let's just get into a friendly 10. It's just written vertically. Same thing we looked at earlier. It's just a transformation, but it's written vertically. And then they think about it this way. Just add 2. We're adding 2 because we want to just take a 10 from it. Take friendly 10s from it.
The cool thing about that is you can show that on a number line or a bead string. You can take 2 colors of clothespins on a bead string and attach it to the 46 and the 36. One color to the 46 and the same color to the 28, and then move them up to, and you can see how the distance between those do not change.
Mm-hmm.
And that is so important for our kids to understand, that if I do something to the top, I'm doing it to the bottom. This goes right back to when they're going to get into algebra later. So it's a good setup for that.
Yes, very good point. Very good point. Yeah, just always remember to explain to them using that number line that when they're subtracting and we're using that transformation strategy, whatever you do to one number, you have to do the same number, and the reason behind it. They need to see why they need to do it, because you're keeping that distance between those 2 numbers the same. You have to let them prove it to themselves. So put those tools in their hands and let them prove it. Let them experiment with it and see what's going on with it.